Okay, 45 has no illustration, but we could see already it's talking about cubes. All right, so cube-shaped blocks are packed into a cube-shaped storage container. So a cube is one where the length of the side are always equal. So if we want to say, let's see, this is a cube-shaped block, okay, and a cube-shaped storage container, it can be larger, obviously. I don't know how much larger, but we're going to have some of the same thing. The lengths of all the sides are going to be the same. Okay, so it's telling us, so this is a cube-shaped container. It's telling us that there's a bunch of CSBs all stored inside of here, all stacked up, right? So it says the edge of the storage container is 2.5 feet. So since it's a cube, this is 2.5 feet. Okay, this here is also 2.5 feet. Okay, and the height, the so-called height, is also 2.5 feet. Okay, everything's in feet so far. So we have no unit conversion problem so far. Okay, the edge of each block is 1/5 of the edge length of the storage container. So this is the storage container here. Okay, and this is the block. So it's not telling us it's 1/5 of a foot. It's telling us 1/5 of the side length. Okay, 1/5 of it. So what is the volume of one cube-shaped block? All right, so if the length of the sides here are 2.5 feet, and this buggy here is 1/5 of that. So when I say I normally mean multiplication. So I'm going to multiply this by 1/5. Okay, so I'm going to convert this into a mixed fraction. That's 5/2 times 1/5. The 5's cancel out, and I get 1/2 of a foot. Okay, so that means the side length of here is going to be 1/2. The side over here is going to be 1/2, and the side over here is going to be 1/2. Yeah? And the volume of a rectangular prism is normally the length times the width times the height, and particularly in the case of a cube, it's the side length cubed. So what we have is you're either going to get one, depending on which way you want to do this, 1/2 times 1/2 times 1/2, or if you use this one is using that, or it's 1/2 cubed. No matter which way you do it, you're going to get 1/8 of what? These were all feet, so this is 1/8 of a foot. The volume is 1/8 of a foot cubed, or cubic feet. All right? So that is 45. All right? Pretty kind of deep problem. Lots going on there. We also could have done it a different way, which involves more multiplication for sure. We could have got the volume of the container. And by the way, before we move away from this concept of half, if the length here, let me change the colors to make this clear what I'm talking about. If the side length of any of the container was 2.5, right? And we split it into 5 pieces, right? We're going to have 1, 2, 3, 4, 5 cubes along the front there. Okay? Right? That's what it's saying. It's 1/5 of the edge length. Right? So that should be clear that we're going to divide this 2.5 feet into 5 pieces. So it's going to be 1/2 plus 1/2 plus 1/2 plus 1/2 plus a half, right? That's how we're going to get 1, 2, and a half, right? So we can see visually, and it's the same thing along here. There'll be 5 parts there. And going up and down, there'll also be 5 parts there. All right? So what we want to do is that the other solution would have been to do 2 and a half cubed. And there's a couple ways to do that. We could have gotten 5. We could have converted it to 5 halves cubed. Okay, so that would be 5 times 5 is 25. 25 times 5 is 125. You guys should know that. And 2, 4, 8. So we get 125 over 8, right? Feet, cubic feet, right? So that would have given us that. And if we divide 8 into there, we get 1 with 4 left over. This is what, 6? No, this is 5.0. 45. That would be 6. Another 0. We get 2 left over. That would be 16. That's 2. Another 0, 16. We get 4 left over, 5. We would get 15. So this is 15.625. So the volume of this is equal to 15.625 cubic feet. Okay. And we need, if we wanted to, because it's by 5 this way, by 5 this way, and by 5 this way, we could divide that by 5, get that result, divide it by 5 again, get that result, divide that by 5 again. As you can see, this gets into a lot of messy math, okay? But we should still end up back with the same answer, okay? And by the way, instead of this 5 halves, we could have gone 2.5. So 2.5 times 2.5 is 6.25. Okay, and multiply that by 2.5 again. I have no idea what that is. I'm not going to do that live. But whatever we get, it should have given us the 15. So 6.25 times the 2.5 should give us the 15.625. All right, so I'm going to leave that as an exercise of the reader for you guys, or the listener, to figure that out. And if we wanted instead of dividing by 5, dividing by 5, dividing by 5, if we view it as 1/5 times 1/5 times 1/5, well, that's equal to 1 over 125. Okay? So what we could have done was the 15.625 over 125. Okay? And that should give us the same answer, which goes back to the original thing, which would have been the 1/8, right? The 1/8 was the original answer, which is the volume of the little cube. All right? And, well, by the way, all you guys should know your fractions as well as decimals. That's 0.125. Actually, you know what? Here's what I'm going to do. I'm going to bring up my calculator just to see if I put my foot in my mouth here. Give me 1 second. I'm actually going to see if that division, those nasty numbers I brought up before, actually brings us into that situation. Let me see if I still have this loaded in here. Is the calculator thing, does that work? Yeah, there we go. All right, so let me see here. What is the numbers I have? 15 point, where are we? 625? 625 divided by, what did I say, 125? Oh, yeah. Oh, yeah, 0.125. There we go. All right, so let's get rid of the calculator. All right, I earned my pay for this YouTube for sure. All right, let me get the calculator off my screen too, because I don't want clutter going on. Oops, did I just kill the stream? Why is the calculator not leaving? The calculator is freezing up my computer, I think. Nope, it just got goodbye, calculator. Okay, let's see. Where am I? Where am I? Where am I? I'm happy that I ended up doing that calculation correct. All right, so this is about geometry. We had to do the visualization ourselves and draw the shape. Could have done it in your head, but it's always worth on questions like this putting that kind of stuff down. It was methodically going through here. So the key is this cubing factor. We either had it, let me change the colors one more time. Let's say green. That might be our good thing here. Dark green. Key was doing this division by three times here. Or the analogous one was, where are we? Well, it was getting this 1/8 cubic foot here. Also getting this here, right? It was knowing that we had to apply on the cube. We had to apply the length, the width, and the height. There's 3 dimensions. So when we do this fifth thing, we can't just apply the fifth one time. We have to apply it 3 times. 3 times. Okay? That was the crucial thing here. Because enough students will get all the correct numbers, and they'll end up multiplying it by the 1/5. All right? And be careful. Follow this through. I would replay this whole answer, because this is a good deep question. Just to be sure that you know when you're multiplying by a fifth and when you're dividing by a fifth. Enough students are going to get the original calculation, which was the, where is that? All right, I can't find it. And instead of multiplying by 1/5, they will end up dividing by a fifth. Okay? But it says of, the length of, actually is this of that's important right there. If it's 1/5 of the edge, so it's 1/5 times the edge. Okay? That's what we're trying to do there. This does not mean the edge divided by 1/5. This is the edge times 1/5. For instance, if it said it was twice the edge, none of you would have a problem by saying it's 2 times the edge, right? So it's 1/5 of the edge. That doesn't mean it's 5 times the edge, right? Division by a fraction is reciprocal and all that stuff. So use the numbers that they're giving you guys, all right? And that's the main, well, there's a couple of gotchas, but a student who can figure out everything else often gets screwed by that gotcha. So the 2 gotchas is that of means multiplication. The second gotcha is you have to apply the 1/5 of the edge to every side that you're doing the volume multiplication on. All right? All right, so and again, your answers in cubic feet. Oh yeah, booyah. And check out GregsTutoringNYC at gmail.com/hottest-math. You can email me at the bottom, GregsTutoringNYC at gmail.com. And I'm going to give you guys double piece again. Where's the camera? Right there. Yeah. All right, guys, take it easy.